In the last class, we were talking about XML, and we were talking about a very important concept called as validating the XML documents using DTDs. So basically, if you want to define the structure of an XML document, I said we got two options. One of the option is DTD and the other one is schema definitions, XML schemas, right? So both DTD and the XML schemas are actually used for validating or checking the well-formedness of an XML document. For validating the well-formedness of an XML document, we use DTDs or XML schemas. Okay, yes. So here you will find that DTDs are less expressive compared to the XML schemas, right? And we were talking about XML schemas. The last thing was regarding the XML schemas and how different are XML schemas from DTDs. You know that we can add, we can specify the element type. That means, we can specify, it is more expressive where we can provide the details about what data particular XML element should hold. Okay, what data a particular XML element is supposed to hold, and you can add restrictions on the elements, right? So that is what we were talking about in the last class. You see, here we can add restrictions, and actually we can specify a particular element type in detail. You see, for example, here what we are doing, we are providing the details about an element called as age. We are providing the details about an element called as age. So this age element, it is what type of element? Simple type. What do we mean by simple type element? Yes, what do people think? What do we mean by simple type element? Simple type element means, no, not root element. Simple type means in this element you will not have any, yes, sub elements. Yes, there won't be any sub elements in it. Child tags or sub elements. Generally in this element will store data. These elements generally hold the data, that's it. There won't be any sub elements. Next, the restriction here, it indicates that we got some validations which we want to apply to this element, or some restrictions. What is it? We don't want the value to be less than 0. The minimum value here, the least is 0, and the maximum is 120. That is a restriction which we have added. That's it. We are able to also specify what type of value the element takes basically. This is integer. Okay, integer element. That's it. You will find that here there is another element called as card. It is also a simple type element. Basically, there is this in this star element, what type of data will be stored? String. The string type which we have mentioned here, is it Java type? Not at all. Okay. It is not Java type. Then what it is? Yes. It is basically XML type. Okay. And even we got a restriction here. This enumeration, it indicates that we got few selected values which we want to store here. Only those values are permitted or allowed in this element. What are those values? Audi, Golf and BMW. That's it. Next, here, let's say, actually, I'm sorry, here, this restriction, it indicates that this element called as letter, the element called as letter should only have alphabets that too in small case from A to Z. You see the pattern indicates that we want the values to be from A to Z, that's it. Okay, only a single letter, that's it. Here, this way, we'll be adding the restrictions. This way, we'll be adding the restrictions. Okay. Now, here, we got another restriction. Yeah, hello. Yeah, hi. Yeah, the class is going on actually. Yes. Okay, I think you didn't join from the laptop, right?
Yeah.
So could you please join from the laptop as well? Okay, and yeah, if there is any possibility, yeah, try to make sure that so that you can share my screen. Yeah, yeah. Basically, if it is laptop, you can share my screen. Okay, so here we got another element called as initials. And this initials element has got a restriction. What is it? We want to store only 3 characters in this initials element, and all the 3 characters should be in uppercase. All the 3 characters should be in uppercase. That is the restriction. Okay. So here, what if the character instance, I'm sorry, here it is clearly specified that it is alphabet. Okay. Yeah. A to Z. Each character can be from the values can be alphabets from A to Z in uppercase. That's it. And similarly, what if I won't allow any of the case, like the small case or uppercase is permitted, let's say. In that case, you will use this pattern. Small a hyphen z and caps A hyphen z. This indicates that any character is allowed. That means it can be, so the characters can be in small, the alphabets can be in small case, alphabets can be in small case or in uppercase. Anything is permitted. That is what it indicates. Yes. Okay, fine. Now, here we have various options. You see, if it is alpha, if it's numeric values, let's say I got an element called as prod ID or product ID. That product ID should be an integer value with how many digits? 1, 2, 3, 4, 5 digits. Okay, the product ID should be 5 digits here. In the product ID, you should have 5 digits. Okay, so there can be few more restrictions here. You see, what is this restriction indicates? Can someone tell me what it indicates? What does this restriction indicates? Yeah. So this indicates that actually the first character, it can actually here, the element here can be a string, but the first character should be in small case. The element can be a string with alphabets or anything, characters, set of characters, but the first character should be in small case. Okay, yeah. Not first, I'm sorry, all the characters. All the characters. Here it is all the characters. Yeah. And there are various patterns. I want you to examine them. Okay, please go through this restrictions which you got here. I'm actually pasting this link in the GoToMeeting chat. All of you please copy this link and save it somewhere. Later on go through this restrictions. Okay. So now generally, where is this XML details stored? Schema details. Where are the XML schema details stored? Now generally, XML schema details or XML schema definitions. XML schema definitions are stored in a file whose extension will be .xst. .xst. So if you come across a file whose extension is .xst, then you should understand that this document or this file contains XML schema definitions. Okay, yeah. You know, here how do we associate this XML schema definition to an XML file? So that you see, whenever that XML document is parsed, first of all, you know, the parser can check for the well-formedness of the XML document. How can we do that? Yeah, I will show you. Actually, we have already used a lot. I'll show you. We have done that already. We have used it. Once I'll show you this. Okay. Here, you'll find that you got this web app element, right? Here, you'll find that the details about the XST have been provided. So here it indicates that this XML document, it follows this XST. The XML document, it follows this XST. Here it is. So if you want, you know, actually it will be available online. You can check for this access to. You can check this access to. Just a second. Here is the XST, which contains the schema definition for that XML file, web.xml file. So what are all the legal elements you can add in that XML document? They are configured here. So this way we can bind an XML schema to an XML document. Okay, so we use this XML NSXI XML schema instance. Then we'll configure the details about that using the URL here. Okay, yes. Fine. So the parser, whenever it reads this XML document, first of all, okay, it will refer to that XML schema definition. It will check whether this XML document is well formed or not. Okay, if it finds that the XML document is well formed, further it will process this document. Okay, we'll read the data from the XML document, and accordingly it will transform it, convert it according to our needs. Okay, so and now it depends upon what parser we are using again. Yes, fine. So now you people understood this XML schema definitions, right? So here, you know what? The next thing what we'll do is, now we'll try to understand how to process the XML data in Java. Okay, given an XML document, okay, let's say I got an XML document. In that XML document, there is some data. What I want to do is, I want to read the data which is in that XML document. That means process that XML document and read the data. So how do I do that? Definitely there is a very good support in Java. You'll find that there is an API called as JAX-P. JAX-P, but JAX-B and P also. First we'll see JAX-P. So JAX-P here, it stands for Java API for XML processing. JAX-P, it stands for Java API for XML processing. Okay. Here, you will find that this API is further classified. One is DOM and the other one is SAX. One API will be based on the DOM, will be based on DOM parsers, I can say. The other one is SAX parsers will be there. Okay, based on the DOM parsers and SAX parsers, you'll find that you got appropriate APIs. But before we move on any further, first of all, it is very important to understand this parsers. Okay, it is very important to understand what is a parser. So, parsers are programs basically which are going to help us to parse or process an XML document, I can say. Okay. Yes, you'll find that there are two popular parsers. There are two particular popular parsers, okay, which are accepted worldwide. One is DOM parser, the other one is SAX parser. But before that, first of all, let's see what a parser does basically. Okay, just a second. So what is the role played by the parser here? You know, a parser basically it helps an application. It can be any application basically. A Java application, a .NET application, a JavaScript, C, C++, whatever it is. Okay. Parser, what it does is it helps the application to parse the XML document. Yes. The parser, it will simplify the process of reading the XML data from the XML document, I can say. Okay. Here you'll find that there are two different types of parsers in Java, in XML community. Two different types of parsers. One is DOM parser, the other one is SAX parser. So here, first of all, we'll be talking about DOM parser. DOM stands for Document Object Model. DOM stands for Document Object Model. And this parser, you know, the base for this parser is this DOM, Document Object Model. So what is this Document Object Model? I'll tell you. You know, here we can use this DOM parser. If you use a DOM parser to parse an XML document, if you use a DOM parser to parse an XML document, you know what it does? It will actually read that XML document, and it will convert that XML document into a DOM tree. Yes, it converts that XML document into a DOM tree. Document Object Model tree. So what is this DOM tree here? What do we mean by a DOM tree? You know, Document Object Model tree, or DOM tree, is basically a data structure. Okay, is basically a data structure which we use to represent an XML document. It is basically a data structure which we use to represent an document, I can say. Yeah. So the data structure contains the details about the XML document. Let's see how this DOM looks like. Okay, XML DOM. So it's important to understand the DOMs first of all. XML DOM. Sorry. So XML DOM is basically a tree structure. See, this is how it looks like. This is an example of an XML DOM. Here, you will find that this XML DOM, in the XML DOM, we got elements, nodes. I'm sorry, we got nodes. In this tree, we got nodes. Okay, here you'll find that this nodes, basically each node here it represents an XML element. Each node it represents an XML element. Okay, so the DOM tree which you're looking at here, it is for an XML document which contains bookstore details. Okay, I'll show you just a second. To work with DOM parser, you have to understand this. Sorry. In order to first of all, in order to work with DOM parser, you should know this DOM tree first of all. Okay, this is the XML bookstore XML document which I'm talking about. This is an XML document, okay, which contains the bookstore details. In a bookstore, you'll have various books, right? So each book, has got again details. Every book will have details like category. Every book belongs to a category. You got a title for this. You got an author for this. Year, price. There can be more than one author also sometimes. Okay. Here, you will find that this XML document, it contains the details about a bookstore, right? Yes. You see, when the DOM parser, it reads this XML document, when the DOM parser reads this XML document, you know what it does? Here, it will actually construct a DOM tree for this. The XML DOM parser, sorry, the DOM parser, what it does, it constructs a DOM tree, and the DOM tree looks like this. Sorry, the DOM tree looks like this here. You see, here in this DOM tree, we got a root element called as bookstore, right? You see in the XML document, the root element is bookstore. So for that bookstore element, you got a node object here. You know what? In the DOM tree, these are all objects basically. Okay. Okay, this each node is nothing but it's an object basically. Yes, each node is an object. It's a data structure. It's a tree data structure. What you're looking at is a tree data structure. If you use a Java-based DOM parser, it will construct a tree, okay, a DOM tree, and for each XML document, for each XML element in the XML document, for each XML element in the XML document, the DOM parser will create an element object or a node object, I can say. It creates a node object. See, these are all nodes. Bookstore is node. Okay. And you see again here, for this book element, you got book element, right? Again, it creates another node here, another node called as book. And similarly for the attribute also, it creates a node. And you see under the book element, you got sub elements like title, author, year, and price. You got different elements here, right? Sub elements. These are all considered as child nodes of book node. These are all considered as child nodes of book nodes. Okay. Yes. You see here, you will find that for each child element, again a node object is created, and it will be under this book node. You see, you got node objects. You see title, author, year, and price. These are all node objects. You know what? In the DOM in this DOM tree, you will find that the elements are actually they are divided into different. They are classified into different types. The elements are actually classified into different types here. Okay. Yes, you'll find that the elements are classified into different types. So that bookstore is actually root element, right? For that root element, a root node is created. A root element, a root node object is created. Yes, a root node object is created. Similarly, you see, for book element is a element. Book is an element node. You see, for that node, for that element, XML element, a node object is created here in the DOM tree. A node object is created. Okay. Yes. So you will find that here, for each XML document, an appropriate node object is created here. You see, again, in the elements, in the XML elements, you'll have data, right? In the XML elements, you'll have data. See, everyday Italian. This is this is the data which is in title element. So first of all, for title element, a node object is created. Basically, we call it as an element node. Element node. Book is also an element node. Bookstore is root node. Where in the document, in the XML DOM, in the DOM tree, we define the elements this way as node objects. You see, what about the text here? You see, for the text also, a node object is created here. Have you noticed it? For the text also, a node object will be created. And actually, you'll find that for the text elements, for the text data which is in the XML elements, text nodes are created. Text nodes. These are other type of node objects. Okay. Yes. This way, you see, you'll find that different types of objects are created. in the DOM tree. Okay, and all these objects are part of, these are all the nodes in the tree. These are all the nodes in the tree. And you know what, here, what is the purpose of creating this DOM tree? Why the DOM parser will create this DOM tree here? How can we use this DOM parser? How can we use this DOM parser? So you may have a question, right? Yes. Sorry, how can we use this DOM tree? How can we use this DOM tree? You know, this data structure, I said the DOM is basically a data structure. A DOM tree is a data structure which contains the details about the nodes, right? All the details about that XML elements are stored in the form of node objects here, the data structures. Okay, so you will find that here we got an API to read this nodes, to browse through this nodes. We can traverse through this nodes using the API. We got an API called as DOM API. You know, the JAX API which I was talking about. Okay, here you will find that we can use this JAX API. You will find that there is support for accessing this DOM tree in the JAX API, and we can browse through this nodes. We can traverse through the nodes. We can read the data from the nodes. Okay, we can manipulate the nodes. We got many options here. Okay, yes. So this way, reading the data from this DOM tree will be easy for us. Okay, so one step forward for us. The DOM parser is making the things a lot easier for us. So you don't need to worry about parsing the XML document. Okay, checking for the well-formedness of the XML document. Okay, and the XML document is not Java based. So you will find that here in Java always we work with objects, right? So here DOM parser, if you use a Java based DOM parser, it will convert this complete XML document into a DOM tree, and DOM tree is basically a data structure which contains node objects, all the node objects here. Yes. The parser will do that for us. Yes, we can validate it. That is what I'm saying now. Parsers, functionalities, that what they will do, they are responsible for validating the XML documents. Yes. So here, now you can just make a note of few points which you got here regarding the XML document. First of all, XML DOM defines a standard way for accessing and manipulating XML documents. So this is a standard way to access the XML documents. How we don't, using a Java application, you are not going to directly access an XML document. Instead, you see, we'll use this DOM which contains, we will use this DOM which is a data structure to access the data. Okay, yes. So the DOM, it represents that XML document. Okay, through this DOM, we will read the data which is in that XML document. Okay, so basically all that XML data, all the data which is in that XML document, basically whatever the data which is in the XML document, you'll find that here it is transformed into DOM tree, and it is stored into the DOM tree, okay, into the node objects of the DOM tree. Yes, fine. So you see, DOM presents an XML document as a tree structure. That is what I was saying. So basically, the DOM is used to represent an XML document, or it presents an XML document as a tree structure. Okay, yes. So next up, you got few more details, I think, which you need to know. As I said, in a DOM, you got different types of elements. Okay. First of all, the entire XML document the entire XML document, it is actually considered as a document object. Okay, DOM parser, what it does is here it represents the complete XML document as a DOM document object. Okay, that entire XML document is considered as a document object here. Okay, yes. Next, each XML element, as I said, every XML element is considered as a node object. They're considered as node objects. But again, the nodes are divided into different types. As I said, even text data, the text content in that XML document is also represented as nodes. Even attributes are represented as nodes. Okay, yes, everything in the XML document is represented as a node here. A node, N-O-D-E, node. Again, you know what? Further, we can classify the nodes into different types. Okay, yes, I'll show you. So basically, you'll have element nodes. Generally, the commonly used types I'll specify here. Okay, one is root node, the other one is element node, the other one is attribute node, the other one is text node, and the comment nodes. And you will have document node, but document node actually it represents the whole document itself, the complete XML document. Okay, yes, fine. This way, the nodes are divided into or classified into different types. Okay, now here, how can we use this API or use that parser to parse the XML document? Okay, yes. First of all, let's see how to actually convert that XML document into a DOM tree. That means a tree data structure, okay, which contains set of node objects. So first of all, let me create a project here. XML project. Now we need an XML document. So here I'll copy this data, XML data. We'll create an XML file here. So I'll call it as bookstore XML. And I'll add this data here. Okay, yeah, just a second please, just a second. Yeah, I'm sorry. Okay, I'm back. So yes, this is regular Java project itself. This is just regular Java project. Okay, you don't need any additional stuff here. Okay, to work with JAX for this JAX-P API. Okay, fine. Now, first of all, okay, we'll see validation stuff. Okay, but we need a schema for that. But I'll find a schema for this XML, sorry, for this bookstore later on. First of all, we'll try to straight away, convert this XML document into a DOM tree. For that, we'll use a parser, as I said. I'll create a test class here. We'll call it as test. Here, now, the first thing we have to do is, if you want to use the DOM parser, you need to first obtain the DOM parser object reference. And you know that in Java, everything is represented as an object. Okay, yes, even DOM parser is an object. Okay, so here, you know what, to obtain that DOM parser object, we are going to take the help of this API. So first thing what you have to do is you have to create a document builder factory object. We have to create a document builder factory object using this method called as new instance. There is a static method called as new instance in document builder factory, and where it is, you see the JAX-P API which I was talking about, the package, you see JAX Java x.xml for parsers. Okay, Java provides a parser here, but actually this document builder factory, what is it? The document builder factory, it's an object and here, this is a factory object for creating document builder objects. What is document builder object? I'll tell you. Okay, don't worry. Here, what we are trying to do is we are trying to obtain a parser object here. So it's a factory object for creating document builder objects. So using the document builder factory, we'll create a document builder. So here we'll get a checked exception. We have to handle it. Yes. You know what? This document builder itself is a parser. Document builder itself is a parser here. Okay. Yes. So document builder, actually it's a parser. It's a Java parser which will read the XML document, and what it does, it will actually convert that XML document into a DOM tree, and that DOM tree contains node objects, basically, which are Java objects itself. Okay, yes, the DOM tree, it's a data structure which contains Java objects now. Okay, each node object will be a Java object itself, so which we can easily access here in the Java application and read the data, okay, which is stored regarding a particular element. Okay, each node object, it holds the data of a particular element, right? Yes. So this is the document builder is the parser here. Please make a note of it. Okay, don't try to search for the keyword called as parser. You won't find any parser keyword here. We are not using any term called as parser. It doesn't mean that there is no parser here in the application. So document builder itself is a parser. Okay, yes, document builder itself is a parser. Now in the document builder, we'll find the methods to parse the XML document. Okay, so how we are creating the document builder object? Using which object we are creating? Document builder object. Yes, builder factory, document builder factory. Okay, so using document builder factory, you will be creating a document builder object. Now let's see how to parse that XML document. When the XML document is parsed by the DOM parser, what it does, it will transform that XML document or convert that XML document into a DOM tree here, right? Yes. Fine. Let's see. Here, in the document builder, you find a method called as parse. Parse method is there. This is the method which you're going to use to parse an XML document. Okay? The parse method is used to parse the XML document. Yes. So to this parse method, okay, what we have to pass? We have to pass the XML file or XML document details. So XML document here, it is in this project itself. So the name of that XML document is what? Bookstore.xml. So it's simple. I'll pass that name here. .xml. That's it. Okay. Now, you know, this parse method actually throws a checked exception. So you have to handle that. So I'll use throws clause. Fine. So what should be the result of this parsing? Once the parse method is done parsing the document, what should be the result here? What do you people think? What the result should be? Yes. The result of parsing the XML document is a DOM tree. You should get a DOM tree here. Okay. Should get a DOM tree. Yes. You know, that XML document, how is it represented by the DOM parser? I said how the DOM parser represents XML document. How the DOM parser represents XML document. No. Okay, as a node, but what node? At least look at this list and tell me. Document node. Okay, document node. So the parse method will return a document object which represents that XML document. Okay, parse method represents an XML document. Sorry, it returns a document object which represents the DOM tree now. I'm sorry, it represents a DOM tree. DOM tree, the DOM tree completely is related to a particular XML document, right? Yes. Fine. So you got the document object here. Okay, you got the document object. So what we'll do with this document object? So now here, we'll take this document object and we can browse through that nodes in that document, in the DOM tree. Okay, document object, now I can say that it represents the DOM tree. Document object, it represents the DOM tree here. Okay, yes. So what we can do is here, we can access the nodes using this document object now. Okay, yes. You can access the nodes using document object. Yes. Okay, fine. So let's see how to do this. You know, I want to find out the details about the root element here. I want to find out the details about the root element. Okay, yes. what to do. So, you'll find a method called as get child nodes or no, just a second. First child. Get first child. You know what it does? Get first child here, it returns a node object. I said there are node objects, right? So basically, in the DOM tree you have node objects and they are represented by this class called as node. These are all predefined classes. Okay. That node object is represented by this class called as node. Okay. Yes. Now here, you see, we'll read the node. What is the first child of the document node? Document object. What should be the first child of the document object? The first child of the document object should be the root node itself. Root node. The bookstore should be the root node. Should be the first child of the document object. Okay. Let's see. We'll try to read that name. Node dot get node name. You got a method called as node name. You see, you'll find the methods here to read the details. Okay. Yes. So this is how it works. Now let me run this code and let's see. Yeah, you see it prints bookstore. It prints bookstore. What if I want to access the other nodes? And under the bookstore, you got child nodes, right? What are the child nodes of bookstore? What are the child nodes of bookstore? Okay, I'll show you the XML document. Direct child nodes of the bookstore. What are they? Book nodes, right? Book nodes. Yes. Book nodes. That's right. Okay. Here, each book node, it is a child node of bookstore. So how do we read those details? Now you got the node object, right? This is basically this node object. It's a root node. Now you want the child node details, then we got a method for that. Okay, I'll name it as root node. That's it. The reference variable name. If you want the details about the child nodes, then you get child nodes. That's it. Okay. Here, what it does, this method get child node, it returns a node list. It returns the node list. Okay, you can think of it as it's similar to your array list. Okay, so the node list, what it contains, the name itself indicates, it contains list of node objects. And each node object, it represents a child element, a child node. So how many child nodes are there? 3 child nodes, right? So in the node list, you should find 3 child nodes. Okay. In the node list, you should find 3 child node objects, the book node objects especially. So, and further we can actually process this XML document, but I'll do it in the next class. Okay. So due to time constraint, I'll stop it here today. then the next class we'll see how to actually read the child nodes as well and completely read the data from that DOM tree. So now we are trying to access the DOM tree, right? So we'll see how to completely read the data from the DOM tree, access all the nodes in the DOM tree and read the data, and then we'll see how to validate the XML document, and then we'll see SAX parser. So once we are done with the DOM parser, we'll see SAX parser. Okay, yes, and then we'll see JAXP. So fine. So tomorrow we should be able to complete DOM parser, SAX parser as well. I hope I may introduce. I believe we'll be done with these two things, and then we'll start with JAXP day after tomorrow. Yeah. Okay, fine. Thank you all.